Hello everyone, welcome to EduSil. In this video, we are going to discuss about divide and conquer approach. In our day-to-day life, we are actually following this approach, but we don't know where we are using and how we are using. So today's session, this detailed video will definitely help you while doing that repeated things, or might be if it is your hobby, then definitely you can know, yeah, you are using divide and conquer approach. Let us begin the divide and conquer approach. So I kept the information from the book named as Corman, written by Corman, named as Introduction to Algorithms. I was telling you in the videos that there are two books I am following. One is Shadows, uh, and another is written by Corman and written by Tados. There are two books I am following. Here, as per the information I kept directly here, but we will go in detail one by one. In general, people are saying it is divide and conquer, but I am basically saying it is divide, conquer, and combine approach. So first of all, we'll focus like how we are doing a problem analysis. Okay, always remember, whenever you are saying divide means you have to divide a problem. So where we are using them, problem could be anything. Okay, suppose you are unaware about a particular problem. Clear? So you need to divide it further until you got a smaller one, as per the definition of the book I'm saying, until a smaller one. Then once you got a smaller particle of it, then you go for conquering it. Means you go for the using the formula of it to do as per the problem, like as per the solution, what exactly you're going to do, as per the steps you're doing that one. And lastly, you need to combine. This is what the book is information. But in real life information, I can say you, whenever we are in a day-to-day life, basically we are eating the foods. Okay, or the different category of foods. Okay, so the uh, basic idea I must say, whenever we are having pizza. Okay, pizza is having four slice, eight slice, it depends. Okay, so different slices are there. Okay, in a circular manner we are actually getting served the pizza. Okay, so whenever we know the pizza is bigger in size as compared to the mouth. Clear? So whenever we have a problem, definitely we know we have to eat it because we paid for it. Clear? So whenever we have purchased it, means we have used our pocket money. Definitely, what our problem, what our solution should be, we have already ordered it and we need to eat it. Okay, the problem is defined now. How you are going to eat it, that approach you are going to follow is divide, conquer, and combine approach. Then how? I'll tell you that one. So when you got the pizza, okay, there might be four slices. Let us think that one. A personal pizza you got from Pizza Hut. Okay. So in that case, there are four slices. Out of these four slices, you have to pick one slice. Means you have to divide the bigger problem into a smaller sub problem. Okay, the problem is divided into sub problem. In generally, you can heard this term always, sub problem, sub problem. The sub problem is a sub part of a problem. Okay, once you are just getting one slice out of these four slices, what you have to do again, that slice also not being eaten by you immediately. Okay, so what you have to do, you have to take it and you have to bite it again. So the slice, the pizza. Okay, there are suppose four slices. Here I have given the example. Then one slice you have kept. Again, that slice could not be chewed by you. Again, what you have to do, this portion you think you can eat. Out of this slice, you got only this much. Means you have to further divide until you are capable enough to chewing it. The, whenever you are chewing it, that is a portion of conquer. Why? Because it need to be stored in your stomach. Why? Because the might be, if you think a protein could be generated, then definitely that could be done. Or energy, if you want, definitely from out like getting the food, then you can expect energy. Clear? So whenever you are chewing, means you need to again doing the work. For what reason? That you need to digest it. For digestion, you need to chewing it further. So the swinging portion is a part of concur. Clear? So dividing is done, like you have to keep as per your mouth, you just divide it. That's why I told you in real life example when we are saying, so dividing, concurring and combining, it depends on the systems that depend on the people around us. So divide that, if a bigger mouth size is there, so definitely one slice could be enough for two chewing. That is not a part of us, but our target is we should know where we are using in our day-to-day life. Basically we are using, and I am following the divide and conquer approach as a well format for me, or well approach for me whenever I am going to give the solution. That's why it is a good topic for me to discuss. Clear? Whenever you are chewing until you are you know taking it, so that time until you are just chewing it, that is a part of concur. You are doing the concurring of it. Once it is getting stored in your stomach, that is what a combine is. Means everything is getting done by you. Like you need to eat the slice, first slice, then second slice, then third slice, then fourth slice could be eaten one by one. But first of all we have to divide it. Divide. So basically we are following the approach whenever we are eating the foods. That time we are actually following the divide and conquer approach, but we don't know before it. So this is what exactly we are doing. So combine, whether it is needed or not, sometimes the question could be arised. Though we know divide and conquer is enough for us, but combine, is it needed for us to do? So I must say yes. Why? Because some cases, if you need to store the value, okay, whenever you need to store a value, like if you think you eat and swing, and that should be directly digested, but where there should be a chamber for it, where you whenever you have chewed it, definitely it should be stored somewhere. Then it should have the process. Without this thing, nothing could work properly. Clear? So that is what a combination must be. And combined, through this combine approach, you need to store using any data structure. That data structure could be basically used as array. Okay, the array, the number of indices will be definitely used as n. If number of indices could be n, means variable, so we can say the space could be big of n due to the array is getting used, as well as the time. If you're using, if you need to use the combine thing, so big of n will be added by default, because you are using array could be different indices. Why? Because you cannot define properly the first time. Means whenever you are doing the divide and conquer approach, the last you need to use the array. In that case, definitely, though you are using array, the time complexity is big of n, as well as the the space complexity, though you are using array, so the space complexity is defined as n by default. Okay, now we are going to discuss about sorting of things. But though after reading this divide and conquer, here we are going to discuss about the merge sort, quick sort. uh, then there are also counting inversions. There are many things to be studied, but still in next videos you can expect such videos. But we should discuss how we find the theme of it. Like I just forgotten to discuss about this recursiveness. So a recursion is getting done. Why and how in real life also I am telling you, when you divide it, when you are chewing it, the same thing is getting chewed, same thing is getting divided further. Means you are calling the function again and again. Okay, you're calling the same function again and again. Why not iteration? Sometimes the people are asking, why not iteration? Definitely you can use it. If you can use it, in that case what will happen, do you know? So iteration, suppose you divide it and you form the array inside it. Okay, you doing it one by one. When you does the first time, have you followed the theme, like whether you chewing it first time, whether do you know it's whether it is well chewed or not? You don't know about it. Like you can take any other example also, but that is why we are not using any array format, sorry, any iteration format. The concur means whenever we are calling the same function again and again, we have the recurrence relation for it, and we know how to frame it. Okay, because there are four solutions for it. When you find a recurrence solution for a recurrence problem or recurrence relation, there are four solution steps. as we have already gone through the different videos. Those who are new for this, kindly visit the recurrence relation videos. So these are the basic difference we should know. The basic approach, basically we what exactly the divide and conquer and combine approach is. Okay, so let us begin with structure. Okay, suppose I must say one array is given to you. After the discussion of it, we will discuss what the search technique is, or what type of search is this. Like suppose one array is given to us, 1 2 3 4 5. We need to find where the 5 is exactly. This is a sorted array. Okay, sorted array. We need to find, here you can say the key terms is, or the value to be found is, value to be found is 5. Okay, from this array what we have to do, we have to first search from one index to another index. That we know, whenever we are searching, by default you can start from this index. Suppose this index is starting from 0 1 2 3 and 4. These are the indices, and the length is 1 2 3 4 5 as per the index. N number of index, n is the length. Okay, whenever you're doing this the you can say normal method, or you can say brute force. Okay, so you can start from first end to the last end, like 1 2 3 4 5, means you have to search one with one, like if condition within the for loop you have to write that, you know the code. That's why I'm not exactly writing for it. If you want to say, so for loop you need to start where I will be starting 0 to 4, or if you can start from 1, that could be 1 to array length, whatever the length will be, that for loop will run. In that case, if condition will run. If condition, you have to find whether key value is index, like suppose this is named as array, whether it is equal to value, suppose the variable name is k. So in that case, whether it is equal to k or not. If yes, then you say the array index, the index value. Okay, or else you can switch it to somewhere. Clear? So else condition you can write, we know we know value found, or the value which has to be decided is not inside the array. So you can write it within the else condition. Okay, now, though you are running the for loop, now you are running the how many times? The number of indices, basically. The number of indices you are running, and for one more time you are going to check, because this is already being discussed in the previous videos. Those who are new, again I am telling you, find the time complexity. There you will get it in detail. Okay, like the number of indices plus one for checking the stopping criteria to stop it. Like we have to be at 4. Now whether we run after that or not, we have to check a condition. So we have to stop it. If array length will be the dead end, then more than array length we shouldn't go beyond. That's why to stop it we need to run for one more time. But within that, the if condition is running for one time, but though it is inside an array, so it is n into 1. So total would be n time. The complexity will be n time, but our target is whether it is less than the n or not. For that, whenever you're finding it, we need to follow the same structure of divide and conquer as I told you. Now we are going to use it. So after that, I'll tell you which type of search is this. Okay, now suppose I am going to use it. You just say how we will divide. You think a mid could be introduced, like we have to first decide a middle point of it. Randomly we cannot take any middle point, there should be a problem. Okay, we should follow certain approach of it. So here we will take the floor function of it. Floor function of what? The last one with the first one. Okay, so last index with the first index. Last index, I must say it here as first index plus last index divided by 2. Why 2? Because from 2 to 2, like that, we have to divide further, and single up to individual we have to stop. That is what it exactly asks you. The problem, again we have to do the sub problem. Next sub problem, 2 2 we have to go for it. Okay, Next, middle part, whenever we are finding out, the mid could be first index is 0, last index is 4. Now we have to divide and take the floor function of it. Floor means the lower value will be picked. 4 by 2. Here no point value, so no need to worry. No decimal value basically. So we can say it's a 2. Here we have to say one more condition we have to also think whether mid is greater than whether mid is greater mid is the key value, sorry, the key value or key, I must say key is named as k. Okay, so here we have set it. If key is greater or less than, that we have to focus. If key is greater than uh, a of the variable a of mid, okay, a of mid, if we will find out, then what we have to say, key was to be 5, now mid is 2. So here it satisfy. If this thing happened, if this, then we will focus on the left half, or the left middle. How it is getting divided, first you check it here. Mid we found. Once we found mid, now I must say the same thing. I must write to 1 2 3 4 5 0 1 2 3 4. From this 2, there are two different half of arrays could be occurred now. Okay, like 0 1 2, here 3 and 4, 4 and 5, here 1, then 2, then 3. Okay, after that what we have to do, it's basically mid plus 1. This is first index, this is your mid index, this is your last index. Clear? So first index with the mid, then mid plus 1 to last index. We have to check further where exactly the number is. To find the last object, sorry, the find the value or the key. What we have to do, we have to go for a condition whether key value is array of mid or not. Array of mid, the key value is to be found out is 5, and a of 2 is 3 now. Okay, so 5 is greater than 3, definitely yes. If yes, then we have to search this portion. I must change the color, that could be easy for you to understand. If yes if yes, then we have to focus on this portion. Clear? If no, then we must say the other half of it. Okay, if no, I must change the color. If no, here also I must say if no, we must focus on this portion of it. Okay, so always we should think these are certain problems, or you can certain rules we should follow while finding the uh, elements. So we found that here uh, is the like we know key is greater than the mid. Definitely we should focus on the second half of it. Okay, in the second half we must write it 1 2 3 4 and 5. Here it was divided into two half. One is 1 2 3, here is 4 and 5. So our next target is, we though we are working on it, then we have to divide it. How? Mid could be the first is like here 0 1 2 3 and 4. 3 plus 4 divided by 2, here is 7 divided by 2. Again you can say it's 3.5. Floor value is 3. Then we focus on 4. By default we know there are two elements, definitely we can divide it in two halves. So 4 and 5, So here again we can check whether the key value is greater than a of mid or not. Like mid is found as like here is 5, a of 3 we know is this half. Like though 5 is greater than 4, we must say though it is, so we can focus on if yes, then a right half. Okay, right half. If no, then left half. In this way, we are going to searching the elements, but that should be sorted. Here we have taken the example of sorted one. So in this sorted, what exactly we are doing? We have to divide it. The problem, first of all, the problem was said to be T of n. Clear? As we are following the recursion, we know as for the recursion, we are taking T of n, or P of n, Q of n, anything, but T stands for time, that's why I have taken. But that should be taken in a function wise. Why? Because recursion is based on a function. That is why we are taking it. Okay. So those who are new, again, I'm telling you, the detailed videos is there in based on the recurrence relation. You just check that. Okay. The problem. This is our problem. Okay, or the bigger problem. Clear? Which was named as a big problem. That will be divided. That is exactly dividing with n by 2. Means you have to divide into 2 half. Clear? That how many times we are dividing? Here one time we have divided. Next we have to divide it second time. This is for the first time. We are going to do the second time division, but the division is only based on one half, the first half basically. Clear? So the one half we are working. So here whenever you say this is T of n, I must change the color. The T of n is now divided into T of n by 2. Here it is T of n by 2. Now this T n by 2 is, here we are working with this T n by 4. But here we are not working. Though we are not working and we are working at the another half, or you can say just the right half, or might be the left half. Okay, though we are, as per our example, we got it as the right half. Okay, so we follow only this half, then this half. So you can say if for right and left there are two different things, but as per our example we found the recurrence relation could be, recurrence relation could be T of n, and though we are focusing on the right half basically, we must say it is T of n by 2. And if actually this is enough, but though there is nothing, so we must say either you can say big of 1, or in simply you just write it 1. Definitely we are running if condition, so for if condition it is 1. So this is the recurrence relation for binary search. Okay, whenever you heard this term binary search, how it is working, this is how it is working. But the condition is binary search will work and it is efficient if it is sorted. If the array we have given is sorted, then only it works. Why we should say what is the time complexity then? As for the time complexity, we know how to find it. I'm just using the recursion one. As for the recursion, I must say the value for T of n by 2 is T of n by uh, T of n by 2 by 2 plus 1. Okay. So here that could be T of n by 4 plus 1. Then T of n by 4, though it is a new term for us, T of n by 4 equal to T of n by 8, then 1. Here this value will be inserted into this one. So those who are new, again just visit that one. I'm just teaching you like how we are getting the complexity. Then you, whenever you combine it, so T of n by 2 plus 1 will be the value first. Next T n by 2, this value will be inserted here. Then T n by 4 plus 1, then plus 1 as it is. This value you got from the upper one. The total value you can expect is 8 plus 1 plus 1 plus 1. Then the next one is T of n. T of n would be T n by 2 to the power 3 instead of 8. I must say it was 8. Now I must say 3 into 1, or you can say the previous was 1 plus 1. That was there, Tn by 2, 1 plus 1. Now I'm just simplifying it, 2 to the power 3, then 3 into 1. Now first let us take k times. We don't know how much time we are going to divide, and we do the conquer about after that. So actually concur part is not being approached here, because we are just dividing it and we are trying to find it out. Concur will be applied if we are going to store it and we need to sort it and we need to display over here. Then only concur will help you, but not always. That is why we are saying divide and concur in general. Okay. So k times, in that case you must say T of n would be T of n 2 to the power k plus k into 1. So in this way that we have also discussed, though here the type here the recurrence relation we found. As for the recurrence relation, in general case we have seen T of 1 is 1, where n is equivalent to 1. Okay. So in this case we found the value in this way, like T of n. Now we thought we reached the base condition. This is our base condition. We thought we reached the base condition. This base condition would be T of 1. Here we must say assume we have reached the base condition. So in this way, when we equate this equation, then we have to equate with the base condition. Now the cost will be equated, n equal to 2 to the power k. As we know, here 2 is there, so only one thing will help you, the log. Both the side you take log 2 to the power k, here 2. Next k will be like this is your logarithmic one, log 2 base 2 equal to log n. Now this is 1, so k value is termed as, or is exactly, we are running for log n time. So indirectly I must say here also for this tree, if you think it's a tree, we are following the height wise or level wise. The level and height is considered, so that is what also we are saying it is log n also. Okay, so here we got the k value as log n. Now we should equate it here for k times t to the power n is considered as t n by 2 to the power k plus k into 1 time it was there. Now you say this is equated as 1, the base condition. Now it is log n base 2 into 1. 1 is constant, so now you can say the time complexity would be big of log n base 2. This is how the binary search is working. You must say, sir, if this is in a sorted order, we must say it is log n. If it is unsorted, chalo. Now we will focus on the problem. If it is unsorted, then whether it will work or not. Definite question is there. I must say, here it is 1, here it is 5, here it is 2, here it is 3, here it is 4. Somehow it is, we know it's not sorted. Okay. So now you apply the same rule, 1, 2, 3, 4. The last element now mid will be found out with the last plus the first, 0 plus 4 by 2. Now it's 4 by 2 will be 2. Now we have to focus the finding here key value, which is k. Now key value you need to find it out as 5. You need to find 5 as a key value. Okay, now you're following it, the same approach. Clear? Now as for this mid value 5, whether it is greater than the mid is 2. Here we have to first divide it. I must write it somewhere. Key k is to be found out as 5, 2. Mid is defined as 2 now. 1, then 5, now 2. 0, 1, 2. Here 3 with the 4. Clear? Now 3, 4. I must say. Now the mid, then we have to find key, whether it is greater than mid or not. Uh, Mid is 2 now. 5 is greater than 2. Whether it is yes or no. Yes. If yes, then what we have to do? As per this one, if yes, we have to follow. If such thing happen, we have to follow the right hand. Okay. But here in this case, what we have to do? We have to. This is yes condition. If yes, we need to go for the right hand. Right hand. But as for the right half we are exactly not getting the value. Okay, we are not getting the value. Then we must say it is not working. It will work in a sorted array, not an issue. Just think, you are not applying this key, you are not applying this mid value, you just focusing on how to find the value. Okay, how to find this key term. If you're focusing on the key term, just assume you are following certain rule through which you can take both the side considerations. In this both the side consideration, what you have to do, n by 2, then tn by 2. First of all, you have to check here. If it is not there, then you have to focus on the right half. Just modify the algorithm cleverly. Suppose in this way, suppose you must say in the right half you are not getting it. If you are not getting it, then you focus on the left half of it. There you have to add one more line, or might be 2 3 lines of codes. There you are working on the left hand side. Suppose you found it. In this case, the recurrence relation would be, is very simple. Don't worry. As per the binary search, it is working in a sorted array. As for the sorted array, only the half will be focused. Means either left half or the right half. Suppose you have done with a clever algorithm. Suppose you said, no, if right half is not there, then we focus on the left half. Definitely, we need to find it. We need to find, our main target is to find the key value, where the index is. Okay. In that case, suppose you are focusing. So the bigger problem will be focused on the first half, T of n, the T of n by 2 from this side, and T of n, I must say, in this way, plus T of n by 2 in this way. Then you add with 1. Okay, because we are not going to combine it, we are just finding out. So here in general I must say T of n would be, T of n will be 2T n by 2 plus 1. Just checking with the n by 2. Now we are focusing on both the half. In this case, what we are getting, you run that one, that will be 2 T n by 4 plus 1, Tn by 4, that will be 2Tn by 8 plus 1. Then you combine it, 2, or this 2n by 4, you can say 2Tn by 4 plus 1. Now plus 1 outside. Here you can say 2 square Tn by 4 plus 2 plus 1. Now for this you must say, okay, 2 square 2 Tn by 8 plus 1, then 2 plus 1, 2 to the power 3 t n by 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0. I'm just converting that 1 is to 2 to the power 0. Now, is there is no power means definitely 2 to the power 1 could be written. Now t of n could be t of n could be written as 2k n by 2 to the power k plus 2 to the power k minus 1. Why? Because here is 3, here is 1, here is 2. That's why 2k minus 1, then k minus 2 up to 2 plus 2 to the power 1 plus 2 to the power 0. Okay. There we will be applying some other rules, but still here it could be negligible. Why? It is focusing on the constant with the GP series. I'm just winding up because it's a detailed video. Definitely we should focus. Where is the problem? That is our main motto. So in this case, that we have discussed already, k value would be like log n base 2. So we just found in the previous one. So if I'll apply it here, the t of n will be like 2 to the power k value if you are writing. So log n base 2, then t of 1, because you have reached and just forget about that one. Now this is you can say a direct formula, because 2 to the power k we found as n also we found, but here also one more formula you can exchange with this one. I know I can write directly, though here we can say when you take the assumption, here also the value is directly for 2 to the power 2 to the power k is like k equal to 1. Now 2 to the power k will be n. That I know. You can definitely apply. But in this case, suppose you are doing that. This is a log formula. Here you can say n 2 and 2. The base will be interchanged with t of 1 plus other things. Just ignore that as usual. Here it is 1. Now here it is 1. Now the time complexity could be n instead of log n. Instead of log n, you are getting the time complexity as big of n. So why not you follow the brute force? In the brute force approach also you are getting the time complexity as big of n. Like 111 index you are going to search, like the first index whether the element is there or not. Second element is the second index whether the element is there or not. Like one by one we are searching until the array length. Also we are doing that one. We are getting the n. But here if the array is not sorted, the time complexity is big of n. Though we are following the divide and conquer approach, there is not a problem for us. But divide and conquer will follow certain steps or certain rules. Then only we get the lesser time complexity as compared to the brute force. There is not always any problem could be focused on this divide and conquer. But in a real life issue, in a real life scenario, we are getting certain solution for the divide and conquer. If something is new to you, definitely you can follow that one. Like the control abstraction is something is abstracted, but how you it is getting controlled, that we are going to discuss. Like the problem is divided into sub problems. Then the sub problem one, once you think it is the lesser one, like one individual, then you do the concur one. Once the up to concur if it is okay, then you stop it here, not an issue. If you need to give the sorted array, if unsorted array is given to you and the problem is defined to be sorted array will be given, in that solution you need to store somewhere, then you need to sort it, then you need to present it. When you need to present it, for that array is playing a vital role here. When you are adding array, when in that case, instead of adding cost as 1 in our example, you just add cost as n. In the next videos we are going to discuss about the divide and conquer approach in merge sort. Then we'll discuss about the counting inversion. Then we discuss about quick sort. Thank you for like I think you understood it. So if there is any problem, you definitely uh, ask in the comment box. Thank you all. Have a good day.